Alrighty, here's example 517. We're going to actually look at it two different ways. Now, example 517, it's using theorem 5.3, and theorem 5.3 again just looks at what if we want to just do a sum of random variables, two random variables. Then in that case we can go straight to the PDF f sub y, and that is our integral from minus infinity to infinity of and they write it either way, so f1, so x1 of y minus x2 times f2 of x2, this convolution, dx2, or you can write it as minus infinity to infinity of f2 of y minus x1, f1 of x1, lost my x2 there, x1 dx1. So that's the theorem we're using. And so in this example, it's really about the bounds, because pretty much, I mean, the integrals are pretty straightforward, but the question becomes, what the heck do these bounds actually mean? And so in this example, we're told that we have x1 is distributed as a uniform 0, 1 variable, and x2 independent is distributed as a uniform 0, 2 variable, and so that means f1 equals 1 on 0, 1, so 0 less than x1 less than 1, and f2 equals 1/2 on 0 less than or equal to x2 less than or equal to 2. Okay, and so if this is x1 and this is x2, then our region that's 1 and that's 2, and we are looking at various pieces here. Here is a y equals x1 plus, x1 plus x2, and if we are working with that now, in our region is always this side when we're asking for x1 plus x2 is less than or equal to y. Okay, because you could write this as x2 less than or equal to y minus x1. So we've got our slope of -1, and if and y has to be greater than or equal to 0. We also know, right, we know right away that y is between 0 and actually 3. Let me write that better, because x1 can be as big as 1 and x2 can be as big as 2, and so this is a curve, x2 less than or equal to like 2 minus x1 or something like that, and certainly that 0, 0, 0 is always going to be a part of that when when y is greater than or equal to 0. So we're looking at this kind of thing, but we have to be within our rectangle here. Okay, so notice that we get different bounds on this thing. So here the picture, here we have this picture. Well, what's y? Well, here y is less than or equal to 1. So let's look at sort of 3 different pictures. Here are my rectangles. First one's not the best rectangle, but hey. So in the first picture here, we've got 0 is less than or equal to y, less than or equal to 1. If we are in something that looks like this, where it crosses both sides, we have 1 less than or equal to y, less than or equal to 2. And then if we're up here, where it crosses the top and the right side, this is when 2 is less than or equal to y is less than or equal to 3. Okay, so those, we're going to have to likely break y up into those 3 pieces. And when we do, we also have to remember that, we have 0 is less than or equal to x1, less than or equal to 1, and 0 less than or equal to x2, less than or equal to 2. And we also have, though, that from this curve that that means that x2 is y minus x1. So this curve becomes 0 less than or equal to y minus x1 is less than or equal to 2. Okay, so solving this one, I have minus x1 is less than or equal to 2 minus y, greater than or equal to minus y. And so if I multiply through by a negative, I have 2 minus y is less than or equal to x1 less than or equal to y. Well, okay, y, we said in here, y is between 0 and 1. And actually this calculation that I did here is going to carry through all of these, but in this case y is between 0 and 1, and so when y is between 0 and 1, if this is whoops, sorry, caught that before we went too far. I took the negative through that, so that's y minus 2. Okay, so if y is between 0 and 1, then this here could go between negative 2 and negative 1. So the biggest it ever is negative 1. But see, that's still fine for x1, because x1 has to be between 0 and 1. But if y is between 0 and 1, then this may be as small as 0 or maybe as small as 1, or maybe as big as 1, but it's something in between, but x1 is bounded by that. And so what this produces is an overall bound on our integral of x1 between 0 and y. Now, if y is between 1 and 2, then this stuff all carries. We still have that 0 is less than or equal to x1, less than or equal to 1, and then y minus 2 has to be less than or equal to x1, less than or equal to y. Now, y is between 1 and 2. So this top bound, the smallest it can be is 1, so that's not a problem. And then here, between 1 and 2, the biggest this can be is 0. And that's all fine, so that's fine. So we will have that for our x1 bounds. And then similarly, 0 less than or equal to x1 less than or equal to 1, y minus 2 less than or equal to x1 less than or equal to y. But now y is between 2 and 3. Well, again, on this end, not a problem. That's just a 1. But here, between 2 and 3, this y minus 2 could be anything from a 0 at 2 to a 1 at 3. And so x1 is bounded below by y minus 2, whatever that is. And so we, in setting this up, our integral back here, this convolution that we do, this part is a piece of cake because we get well, actually I'm doing this part, I'm doing the, oh wait, no, I am here, sorry, x1. I'm integrating with respect to x1, and so f2 is going to be a half and f1 is going to be 1, but I get these 3 different cases. So I have f sub y of y is equal to, well, I have my case for y between 0 and 1. We'll make that a, say, a strict inequality, and then 1 and 2, and then 2 and 3. Okay, so this first one, we had an integral from 0 to y of our 1/2 times 1, so 1/2 dx1. And here we had an integral from 0 to 1 of 1/2 dx1. And finally, for our last one, we had an integral from, what was that again, y minus 2 to 1 of 1/2 dx1. And so what we end up with is y over 2. We just get a half here, and then we get 1 minus y minus 2 over 2, which we can rewrite. So this is 0 less than or equal to y less than or equal to 1, 1 less than, well, strictly less than 1, less than or equal to y less than 2, and 2 less than or equal to y less than or equal to 3. Now this, I've got a 1 minus a minus, so I could, I'm just going to erase this and make that a 3 minus y. And so there we go. That's our PDF. Now that one, you know, I used the x1 and x2, but I would end up with the same sort of thing. So in class, I had looked at this and I said, well, oh wait, where are they getting theirs? They're getting theirs because they did x2. Let's try that. Okay, so if we're integrating with respect to x2, well, we have the same sort of thing, but now when I look at these, so 0 less than or equal to x2 is less than or equal to 2. But now this is the one I have to change. And so I have 0 is less than or equal to, and x1 is y minus x2, which has to be less than or equal to 1. Okay, so same sort of thing again. I get a minus y less than or equal to negative x2 less than or equal to 1 minus y, and so now again using the negative I get y minus 1 less than or equal to x2 less than or equal to y. Okay, so I have those two pieces, and now if y is between 0 and 1, well, if y is 0, not a problem. And if y is up as big as 1, we still just get a 0 here for the lower bound. And so, but the upper bound could be y, because I could have y as a half or something like that. And so here we see that we end up with a 0 less than or equal to x2 less than or equal to y. That is the same bound we had before. Now, if we look at 1 less than or equal to y less than or equal to 2, well, again, looking down here, what we see is that if y is as big as 2, x could be a 1. X2 could be a 1 then, because if this starts at 0 but could go up as big as 2 minus 1, which is 1. And so this lower bound is, in this case, y minus 1 less than or equal to x2. And then the upper bound, well, because x2 could get as big as 2, then this is y. And so, here we have the same lower bound that we did back here, or same bounds as we did back here. Where was it? Right there. Was 0 to y for y between 0 and 1. But now, see, we had 0 to 1 for x1. Now, when we have x2 for that middle part, we now have bounds of, y minus 1 is less than or equal to x2 is less than or equal to y. Okay, so that matches the textbook. And then when we're between 2 and 3, again, looking at this sort of thing, what can happen? Well, y could be 2 to a 3. That means y minus 1 could be between 1 and 2. And so that really is a bound. So we've got y minus 1 and is less than or equal to, and y here on the right-hand side, well, it's from 2 to 3, but x2 is never any bigger than 2 anyway. So x2 is less than or equal to 2. And so these three here match what the book has when they integrate with respect to x2. Okay, so I won't write those integrals down. We just want to see where those bounds came from. And so that's the big thing when you're working with Theorem 5.3 and working with the bounds. You're working kind of with, with the starting point of those, and then the relationship you get from the y equals x1 plus x2. And either writing that as x2 equals y minus x1, or writing it as x1 equals y minus x2. And so depending on which way you go, here I'm going to integrate with respect to x1. Here I'm going to integrate with respect to x2. Okay, so that is example 5.17 in a little more detail than we did in class.